Hey, if you'd like to earn CEUs for this webinar, join the Safeopedia community at the link in the description below. Now, on to the show.
Hello everyone and welcome back to another Safeopedia webinar. My name is Samantha and here at Safeopedia it is our mission to support the EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I'd like to extend a huge thank you to all of our dedicated safety professionals for the great work they do on a daily basis in keeping our workplaces safe. Today we are proud to present Detecting Danger, Gas Safety Essentials for Construction Teams. This Safeopedia webinar has been made possible today by GFG Instrumentation Inc., a preferred manufacturer member of AD Safety Network. AD, together we win. It is now my pleasure to welcome back to you today Bob Henderson. Bob will help you determine how to pick out the correct portable gas detector for the construction industry. I am very excited to have you all sit back and relax and enjoy this presentation. With that, Bob, let's jump right into it.
Awesome. Well, thank you very much for the intro, Sam. I appreciate it. Today's goals are we want to provide you with an overview of the atmospheric hazards associated with construction, and also especially to go over the OSHA requirements for confined space entry. There is a lot of confined space entry that goes on in construction projects, and those activities are tightly controlled by a couple of important regulations. So we're looking to provide some answers to some basic confined space questions. What do the regulations say about gas detection? How do you identify your gas detection needs? What are some of the special confined space issues that face contractors and construction workers that are a little bit different from non-construction confined space entry activities? And how do you ensure that your atmospheric monitors are actually fit for purpose, fit for use? So that's a lot of stuff to get through in an hour, but we'll give it a good shot here. Construction managers deal with an extremely wide range of atmospheric hazards, monitoring applications, and activities. The hazards can be generally present or associated with specific activities like confined space entry. A unique challenge in construction is that hazards can change from day to day as different teams are engaged in different activities. One day you might have an attic under construction because of the use of sealants or solvents. It becomes a dangerous permit required confined space. After the construction is done, however, and the sealants and solvents have completely dried and the vapors have dissipated, maybe it's not a permit space anymore. But managers need to anticipate critical requirements ahead of time and recognize when conditions are changing in a way that requires additional actions to be taken. So questions to ask when you're assessing the hazards. Hazard assessments is a very large part of the responsibilities. You can't determine what kind of gas detection you need until you understand what the hazards comprise and what you need to measure. So this is not an all-inclusive list. That would be not very easily achievable in an hour seminar. This is just a list to get you started, but consider where the construction site is located, what is being constructed, what kind of activities are going on at the site, what kinds of equipment and materials are being used. Always remember to consider human factors. Who's in charge? How is communication managed between contractors and teams? How are known hazards being managed, controlled, or mitigated? How are conditions being monitored to ensure workers are not exposed to existing hazardous conditions? At the end of it all, you have the general duty clause that is always applicable. The general duty clause for employers states that each employer shall furnish to each of his employees employment and a place of employment which is free from recognized hazards that are causing or are likely to cause death or serious physical harm to his employees. So that's an unavoidable obligation. You have to create a workplace that is safe for employees. It's your job as an employer to ensure their safety. And sometimes focusing on that overarching requirement makes more sense than nitpicking over worrying about definitions in specific codes. Don't ever allow the workplace to become unsafe for your workers. What are the specific causes of atmospheric hazards at construction sites? I've mentioned already at least once pre-existing hazards at the site. Your construction project, the project is going on where probably something else has gone on in the past. A lot of times, if that is an industrial site, you have the after effects of what went on beforehand. So always be cognizant, always be aware of what that site was being used for before you turned up. Pre-existing hazards can get you in a lot of trouble. If you have demolition going on or hot work going on, you have introduced additional hazards on top of what other hazards might be present. If you're working in or near confined spaces, that in itself is a hazardous activity in a hazardous location. Tunneling, underground construction can increase dangers and add additional concerns. Trenching and excavation is a way to add additional concerns and considerations. If you're applying or making use of solvents, paints, sealants, foam insulation, other materials that are based on volatile organic chemicals. Now, the VOCs themselves are potentially explosive, but they're also generally toxic at much lower concentrations. Road construction, often that is part of a major construction project. You have, again, VOCs, asphalt, sealants, paint, and the carbon monoxide, nitrogen dioxide, nitric oxide, and CO2 that's present in engine exhaust to be a concern. And then often, if you have a unique project, you may have unique hazards that are part of that project. If you're manufacturing or constructing a line of tanks as part of a metal processing dip tank line, cyanide, other acids might be a special consideration. Not everybody has that. But when you have a special project going on and a special task that needs to be performed, be aware that it can alter or add additional hazards to the atmosphere that need to be measured. Some more examples of conditions and sources of atmospheric hazard, just to be aware of, to think about. Be on the lookout for battery charging stations around the site where you're working. Battery charging often introduces hydrogen into the atmosphere. It can get all the way up to explosive levels under some circumstances. And it can also be an interfering gas that causes problems with some of the other sensors in your instruments. Lithium ion battery handling. If you damage or have a short in a lithium ion battery, you can have the generation of very, very toxic HF gas and a lithium ion battery fire on your hands. Combustible liquid cabinets, gas storage areas, spills, leaks, fueling stations, either hydrogen or propane, all of these are commonly found at industrial sites. And if you're doing work around this equipment and you're in an area where you have these concerns, then that needs to be folded into your atmospheric monitoring plans and equipment as well. Combustion processes. Stack gas includes SO2, other acid gases, NO2, NOCO, CO2. Stack gas, if it drifts into the areas where workers are doing their jobs, can cause them harm. So make sure that you keep an eye on that, and if necessary, you do monitoring to ensure that you do not exceed the toxic exposure limits. And engine exhaust is always a concern on a construction site. You have sometimes at an industrial facility a process going on that deliberately is changing the atmosphere. You have nitrogen purging, you have curing ovens, you have inert gas actuation. Make sure you understand what's going on at the site where you're going to be working. More examples yet. During shutdowns and turnarounds, especially at refineries and chemical plants and mills, you often have an increased likelihood of H2S, VOC exposure, sulfur dioxide, CO, chlorine, NO2. Make sure that you understand what the process is that might be continuing in normal operation outside of the designated work zone that could drift into your direction and cause harm. Landfills, a lot of new construction is on landfills where you have combustible gas, CO2, pocketing. You need to be very vigilant and especially careful with your gas detection when you're building on a landfill. Marine sediments and swamps, again, same thing. You have H2S, combustible gas, heightened likelihood of oxygen deficiency that can occur in pits and trenches through the marine sediments. So keep on your toes. Hazards associated with hot work. What is hot work? Here we're deliberately introducing a source of ignition into the working area. That can be by means of riveting, welding, flame cutting, or other fire or spark producing operation. Welding gases that are used in the cutting process, such as acetylene or ethylene or propylene. You have the byproducts of combustion, CO, NO2, SO2, ozone. You have inert gas, often in TIG welding, where you're doing the welding under a purge of the inert argon. You also have a very high likelihood or possibility, if you're doing the inert gas welding in a confining environment, of creating oxygen displacement and oxygen deficiency, and creating an environment where, without proper monitoring, you can have workers who are overcome and asphyxiated. Demolition. Here, we're also interested or need to be mindful of residual contents in old vessels, in tanks, in boilers that can actually impregnate the ground. It can impregnate the wall of the tank itself. It's trapped in there. It's just waiting for you to heat it up with a cutting torch to get back into the air where it can cause harm. You can't get through almost any construction process project without at some point using paints, polymers, resins, sealants, solvents, and all of these VOC, volatile organic chemicals, are toxic at low concentrations. They're flammable at higher concentrations, and they can cause harm. They can cause a worker to be overcome as a function of acute toxicity. They can cause harm because of long-term exposure, or they can even cause an explosion. So you're going to need to measure them. For VOCs, and chemicals in this category. Typically, we're going to use a photoionization detector type sensor, which can be added to a multi-gas instrument, or you can use a separate PID. And then we get to confined space issues. There are a lot of confined spaces in construction projects. It's one of the largest applications for gas detection. Over 500,000 companies or departments in the USA alone have confined space programs. In the United States alone, there are over 1 million confined space entries per day. Over the last 10 years, on average, something like 129 countable OSHA confined space fatalities are documented. The true total is probably larger because OSHA only counts the fatalities and accidents in categories where they have responsibility. So if it is an accident or a fatality that occurs outside of the scope of OSHA, it's not part of that count. I'm on the I've been a member for a long time of the AIHA, that's the American Industrial Hygiene Association Confined Spaces Committee, and we keep track, the members of the committee keep track of confined space accidents. We share newspaper articles, media reports, and the week does not go by that we don't share among ourselves yet another tragic either fatal accident or accident that has harmed workers. Generally speaking, 2 out of 3 of the people who are killed in confined space accidents, by the way, are would-be rescuers. There is generally low likelihood of a single person being killed. Most of the time, it's 2 or more people killed because of this tendency to suck people into an emergency response that they might not be prepared for. And the rescuer is harmed as well as the original entrant. You need to be well trained. You need to be using the proper equipment. You need to conduct the entry into a confined space in accordance with the requirements, the legal requirements of the confined space entry standards. And if you don't, you set yourself up for all kinds of problems. In 1993, OSHA published 1910-146 permit required confined spaces. So that standard has been around for a while now. But when it first came out in 1993, there was a big gap. It did not address confined space entry into confined spaces that were under construction. So the construction code existed, but it didn't have much to say about confined space entry. There was just this big gap. Well, that gap does not exist any longer. In 2015, OSHA finally published 29 CFR 1926, Subpart AA, that's confined spaces in construction. So the Subpart AA gives you a lot more information as to what comprises a confined space. It does not disagree with the general industry guidelines for permit confined space entry. It takes you a little bit further into explaining the obligations for communication, for use of gas detection, for maintaining and testing gas detection equipment. So there's no disagreements. It's just a little bit more, a little bit more with the explanation and clarification of some issues that are not quite so clear in the general industry standard. So it doesn't really differ. If you rig your whole program along the lines of the construction confined spaces standard, it's going to work for the general industry standard as well. There are no fundamental disagreements between the two standards. The definition of a confined space is exactly the same. A confined space needs to be large enough for the worker to enter. It's not designed for continuous worker occupancy. It has limited openings for entry and exit. Just because it's a confined space doesn't mean it's a permit required confined space. The permit required confined space is a confined space that has at least one additional hazardous conditions. It could be hazardous atmosphere, known or potential, a material with the potential for engulfment. It could be the configuration and shape of the confined space. If it has dangerously sloping walls or floors where you can slip and become trapped, or if it contains any other serious safety hazard. That makes it a permit space. If you have a permit space on your hands, you have three options. If you need to go in, I guess your fourth option is you don't go in. But if you're going to go in, you can, if you can eliminate the hazards without entry and ensure that the hazards don't come back while the entry is underway, you can reclassify it as a non-permit space. If the hazards are exclusively atmospheric in nature, and if the confined space can be maintained safe through the use of continuous forced air ventilation, if you monitor continuously, if you ventilate continuously, you can use what are referred to as the alternate entry procedures for a permit required confined space. A lot of programs are built around use of the alternate procedures. The alternate procedures allow you to do solo entries. They allow you to have an entry that does not require a standby safety watch or a rescue team. When it's appropriate, it's a way to streamline your confined space entry procedures and yet maintain safety. If the alternate entry procedures are not available or would not work, or there are additional kinds of hazards present besides atmospheric hazards, and if the environment can't be maintained safe exclusively by the use of forced air ventilation, then what you're going to do is use a permit that addresses specifically what needs to be done in that particular type of confined space. It lists every single detail that you need to do to ensure workers are safe, and that also includes rescue provisions, and it ensures that it's like the checklist that a pilot on a commercial aircraft goes through. It just ensures that nobody forgets a single step to make sure that when the plane takes off, it takes off safely. Let's go back to the three alternatives. Reclassification as a non-permit required confined space. You can only, and this is if and only if, you can reclassify if the space contains no actual or potential atmospheric hazards, and if all other hazards can be eliminated without entry into the space. And it still requires use of a calibrated direct reading instrument to ensure that when you say, hey, there are no atmospheric hazards, you have tested and determined that that is the case. Reclassification requires that no ongoing measures are needed to keep the space safe while people are in the space. The reclassification is valid only as long as the hazard is eliminated. If hazards are reintroduced, then the reclassification is voided. You definitely need to be out of that area, and you can only return after testing determines it's safe, and you can go through that reclassification process all over again. The employer must certify that the reclassified confined space meets these criteria. So you're leaving a paper trail of what you have done. You've certified that all the hazards have been eliminated. This is a signed document. You're going to retain it for your records and take reclassification very seriously. It is a permit required confined space until through reclassification, it isn't. So make sure you follow the rules for reclassification. Alternate entry procedures. This is a really useful approach in a lot of cases. It maintains worker safety. It's an acceptable way of dealing with circumstances, conditions, confined spaces where the hazards are exclusively atmospheric and where you can completely ensure the safety of the atmosphere for workers through the use of continuous ventilation. And of course, you're using gas detection continuously to make sure that the ventilation is working and that the conditions are continuing to be safe for the workers. So if a hazard cannot be eliminated but can be controlled, then potentially you can use the alternate entry procedures. The benefits, again, lower equipment requirements, no attendance. You can have an attendant if you want, but it is not absolutely mandatory. And if you have a program that includes solo entries under the alternate entry procedures, solo entries are permitted. So here's how you do it. Before the employee enters the space, the internal atmosphere must be tested with a calibrated direct reading instrument for oxygen, flammable gases and vapors, and potential toxic contaminants. What does calibrated means? It means that you have operated the instrument in accordance with whatever the manufacturer says in the owner's manual. If the manufacturer says you need to test the instrument on a monthly basis, that's the obligation. If the owner's manual says that you need to test the instrument or calibrate the instrument on a daily basis, that's your obligation. For calibration, the calibration frequency and circumstances which merit a calibration adjustment to be made are up to the manufacturer of the device. Untested confined spaces may not be disturbed in an unsafe manner. The moment of maximum danger from an explosion standpoint is often before you're physically inside the confined space. If it's a manhole cover, methane, one of the most common combustible gases, which is a little bit lighter than air, can easily accumulate immediately beneath the lid. So if you strike the lid with a hammer, cause a spark, you can actually ignite the methane gas and you can have an explosion. So if you're going to remove the lid, you should take a sample of the atmosphere, if possible, through apertures or holes in the lid, and make sure it's safe to carefully remove the lid and not do anything irrevocable. If you sample through the lid and you find an explosive level of methane, then obviously that is not the right moment to pull the lid in a way that could cause a spark or be the source of ignition. Once the lid is gone, you need to test the atmosphere at every point vertically, all the way from the entrance down to as low as you can drop the probe and draw a sample. There can be no hazardous atmosphere within the space. Whenever an employee is inside the space, you're going to ventilate the atmosphere until The conditions inside the space are basically the same fresh air conditions that you have outside the space. How do you sample from the space? Well, you can always tie the instrument on a string and lower it into the space. It's not my favorite method of testing. I much prefer to use a pump equipped instrument. You can have an attachable pump that you put onto the instrument. You can have an instrument that has a built-in pump. This instrument has a built-in pump with a slide switch that turns it on. If you do not have a pump, you are going to have to lower the instrument all the way down. Typically, instruments will have a peak hold mode, so you can put them into peak hold, lower them down, bring them back up, and check to see what the most significant reading is, and then reset the instrument to go back to measuring and showing you readings for current conditions where the instrument is located. But the peak read function is there to do exactly what I'm talking about, to help you with being able to lower it on a lanyard and pull it back out. But you're a lot better off with a pump equipped instrument. You really want to take that sample through holes in the lid of the manhole, or open that vessel up just enough to slide that probe in and see what's going on the inside of the vessel before you do something irrevocable. Now, it's up to the manufacturer when you do and under what circumstances you perform a full calibration. A full calibration includes adjusting the sensitivity of the sensors to match known concentration calibration gas. Now, there are 3 levels of ensuring that your instrument on a day when you need to use the instrument is fit for use. The first way is to perform a bump test. A bump test is qualitative. All you're doing in a bump test is flowing test gas over the sensors and seeing if the alarms are activated. If the alarms are activated, you know that the sensors are alive. You don't know how accurate the readings are, but you know that the sensors are capable of responding to gas. So that's the most qualitative method of ensuring that the instrument is fit for use on a given day. And OSHA is very firm about the requirement in the construction confined space rule. You should perform a bump test, at least perform a bump test before each day's use, as well as any time that the instrument is dropped or harmed or exposed to conditions or materials that could affect the ability of the instrument to detect gas or affect the ability of the sensors to perform. You want to perform a bump check on it just to make sure that the instrument is still capable. The next level up is called a calibration check. Here, what you're doing is flowing the gas for a long enough period of time to allow the readings to fully stabilize. And when they stabilize, the readings have to be accurate within the manufacturer's specification for the instrument's performance. If the manufacturer says, well, hey, the readings have to be within plus or minus 20%, then that's the determinant. So it takes the process a little bit further. In a calibration check, not only do you know that the alarms are properly activated, but you know that the accuracy of the readings conforms to the specification of the manufacturer. The third level, the ultimate level of establishing whether or not the instrument is fit for use on that particular day, is to do a full calibration. The difference between a calibration check and a full calibration is you're adjusting the readings of the sensor. You let them stabilize, and then If needed, you adjust them to exactly match the concentration on the label of the calibration gas cylinder. So OSHA is very clear on this. They want you to perform minimally a bump check or a calibration check before each day's use. And with regards to performing a full calibration, they leave that up to the manufacturer to specify in the owner's manual how frequently or the circumstances which govern how often you do that. But if there's any doubt, there is never something wrong with the idea of doing a full calibration. A lot of corporations, a lot of professions, like if you're an industrial hygienist, your code of conduct requires you to calibrate the instrument before using it and to calibrate it after use to ensure that you have not lost any capability of or accuracy in the interim. So there's nothing wrong with calibrating the instrument more frequently, but those are the minimums that are set up by OSHA. Uh, Fitness for use also includes the kind of batteries. Make sure that you consider the pros and cons. There are right now basically 3 different kinds of batteries. Each of them have their pluses and minuses. That's kind of a joke. The alkaline battery is still a nice approach. Disposable batteries ensure that you're never going to get stuck with no power. All you need to do is wander over to the nearest convenience store, get some replacement batteries, and keep on going. For rechargeable batteries, one option is lithium ion. Lithium ion batteries are hazmats. If they are damaged or develop a short circuit during recharging is usually when this kind of thing happens. We all have seen lots of newspaper stories about automobiles with lithium ion batteries bursting into flames because of a short or a problem in the battery. If the battery catches fire, it does not even need a source of external oxygen. Eventually, as the fire grows, oxygen from the atmosphere will be sucked in, which supercharges the fire. Lithium ion battery fires are notoriously hard to put out for this reason. So, myself, I prefer to stay away from lithium ion batteries in portable instruments. At my company, GFG, we don't use lithium ion batteries. We use nickel metal hydride batteries, which are not hazardous, which do not have combustible liquid electrolyte, and which do not tend to produce um, uh, thermal runaways and hydrofluoric acid vapor if they're damaged. Alternate entry procedures. The continuous forced air ventilation must be used for the entire duration of the entry. And if the ventilation stops, you've got to immediately leave the confined space. The permit is voided until the ventilation is back in place. And remember that you also are, the idea of using continuous monitoring is that you want to take action at a time when you can exit the confined space deliberately under your own power. You want to make sure that your alarm settings and your procedures allow workers to self-rescue. You certainly don't want to set things up where the only way that the worker is making it out is if there is a rescuer standing by who needs to go into the confined space to conduct the rescue. And once again, under the alternate entry procedures, this is a kind of permit entry. So this is a document you need to fill out. The entry supervisor needs to sign it, and you're going to keep this document. If you need to go in by means of a full permit, now this is going to take more personnel, more equipment will be more involved. There are more steps. But when something is present in the space that provides a hazard, which goes beyond the atmosphere and which cannot be rendered safe by continuous forced air ventilation, this is the method, this is the kind of permit that you are going to be using. It specifies the exact means, procedures, and practices for that space, which will keep workers safe. And it establishes that all of the protective measures have been taken, none have been omitted. Now, 1926, for construction, if you're new to this standard, you might think that, well, holy smoke, I've been working in construction all my life. I don't think that's a confined space. OSHA cannot possibly think that's a confined space. So OSHA went out of their way to make sure unambiguously they have indicated what can comprise a confined space under the 1926 standard. So if you look at the standard, and there are some excellent simplified English training materials on the OSHA.gov website, I'd urge you to download a copy. Confined spaces that you must consider as being potentially dangerous. And remember, just because it's a confined space doesn't mean it's a permit confined space, but you must start with the assumption that it's potentially dangerous until you rule it out. But the list includes boilers, manholes, and this is including prefab cement manholes, precast concrete manhole units, tanks, incinerators, pier columns, sewers, drains, transformer bulbs, HVAC ducts, cesspools, mixers, reactors, turbines, silos, chillers. And remember, you don't have to be fully enclosed for the environment to meet the confined space definition. Open-topped water tanks, digesters, lift stations, bins, degreasers, pits, excavations. These are all confined spaces. Crawl spaces and attics. This one is going to be controversial, I think, for anyone who does a lot of single home construction or building construction. Sorry, guys, it's a confined space. Whether it's dangerous or not depends on what's going on at that moment. But if at that moment you're applying a solvent or a paint or foam that is off-gassing contaminants, maybe it is a permit space until the material has cured and until it stops emitting vapors. So it could very well be a permit space on the day that the sealant is applied. A day later, after the sealant has completely dried, cured, and is no longer producing a detectable vapor, maybe it's not a permit space. It's still a confined space. The issue is, what do you have to do about it? And you're going to have to do a lot more if it's a permit space than if it's a non-permit space. Employers need to identify confined space hazards, inform employees by posting, and also prevent entry by unauthorized people. You really want to make sure that when you leave the confined space, you secure it in a way that unauthorized people can't get into it and get into trouble. Employers need to make sure that all of the required equipment is available to workers involved with the entry. That, of course, includes the testing and monitoring and ventilation equipment, but also anything else that might be necessary, including communications, lighting, barriers, other PPE, and, of course, rescue equipment. if needed. Employers need to establish procedures and practices. You need to follow the rules that is defined by your permit system. You need to train employees. You need to verify that workers are competent. And only workers who have been assigned and trained to work in a permit space are permitted to do so. You need to ensure that all of the equipment is available and used, and you need to surveil to make sure it's being used properly. And you need to control hazards where possible, or permanently eliminate hazards where possible through engineering controls or work practices. You don't want to leave the danger in place waiting to bite somebody when you can permanently eliminate the danger and not have to consider it in the future. Employees must protect entrance from external hazards, hence my listing barricades and equipment to prevent stuff from falling into the confined space. You absolutely must evaluate how you are going to deal with an emergency and how you are going to rescue affected workers who may need to be retrieved from the confined space. Calling 911 if you have an emergency or an accident is not the way you satisfy that requirement. Your emergency procedures must reflect the specific dangers of the confined space. The attendant should never enter the confined space until help arrives or someone who is qualified to take over as the attendant can take over the responsibilities, in which case the former attendant can be the rescuer if needed. But that is not the proper or best way to normally undertake the duties. A better way is to set things up so the attendant can perform the rescue without actually having to enter the confined space. So a retrieval system, the attendant can summon help and retrieve a downed worker or an affected worker without having to enter the space. That is a much better approach. The most dangerous activity is for the would-be rescuer is if you have to enter the confined space physically to conduct the rescue. Remember, you've only got 3 to 5 minutes to retrieve and revive a worker who has stopped breathing before the onset of permanent brain damage. And the only way that that is going to be possible is if you have the standby rescue team immediately adjacent to the confined space. If you waste 5 minutes on the rescue team coming even from a nearby fire station, it's just going to be a body recovery. So make sure that you address the rescue issue. The number one objective is for workers to self-rescue and to leave at a time that conditions are changing in a dangerous way, but have not yet become life-threatening. And the second best approach is to use retrieval systems and harnesses that permit the attendant to conduct a rescue without entry. And the least desirable approach is to have a standby rescue team ready to actually physically enter the space to conduct the rescue. The 1926, the construction rule, really puts a lot of emphasis on communication, because every day at the construction site, you have new people, new faces, new teams that are doing their job at that phase of the construction project. Tomorrow is another day, different faces, different teams, different objectives. So if you have a confined space, which is an ongoing confined space where it has not been, or it's not possible to secure the confined space against entry, You absolutely need to have, in an open confined space, somebody must be in charge, and there has to be a formalized way of trading responsibility to a new guy. If shift is over for the one entry supervisor, there has to be a good track of who is in charge of that confined space any time that the confined space is open. If nobody's in charge, it needs to be secured in a way that prevents unauthorized entry until somebody is in charge and authorizes the entry, and then the confined space can be reopened. So a lot of emphasis on communication. We've already talked about the importance of testing instruments before each day's use. Docking stations make that a whole lot easier. You want to maintain good records as to the maintenance and proper use of your instruments. These are all records that you should keep for 7 years at a minimum. More than that is my general advice. Don't ever get rid of them. Minimally, as I mentioned before, we're measuring oxygen, combustible gas, carbon monoxide, and H2S. The choice of what kind of combustible gas sensor to use is very important. Traditional LEL sensors detect gas by oxidizing it and looking at the temperature effects of oxidizing or burning the gas on a bead within the sensor. This kind of sensor is great. It detects everything from hydrogen and acetylene to alcohol and common kinds of combustible gas, but it's also easy to poison, which is why it's so important to perform a bump check before each day's use. Another new kind of sensor that is popular is the MPS sensor, or molecular properties spectrometer sensor. These are great sensors for use in lone worker instruments or where you're not in a confined space, but they don't detect combustible gas because of its characteristics as a combustible gas. They just look for anything that is different in the density of the air compared to fresh air. So these kind of sensors are pretty easy to confuse in a confined space. In a confined space, it's easy to find a lot of carbon dioxide that comes from decomposition or exhaust gas. You can have carbon dioxide present from a bunch of different sources. Only 2,100 ppm of CO2 to this kind of sensor looks like 10% LEL, heavier than air combustible gas. So not recommended for use in a confined space, recommended for use outside of confined spaces. Another popular type of sensor are infrared sensors. We love standard LEL at my company. We love infrared LEL. We use them at different times for different applications. IR LEL can't be poisoned. It doesn't require oxygen to be present in order to detect gas. It's a really brilliant sensing technology, but what you get out of the sensor changes from one manufacturer to another, and you really want to read the owner's manual. Some of the miniaturized low power LEL IR sensors are really good for methane and nothing but methane. And the only way that you're going to find that out is if you read the owner's manual. And watch out for a category of instrument that OSHA refers to as an alarm-only device. An alarm-only device is one where you don't have a reading, you just have an alarm if you go over the alarm threshold. OSHA has published guidance letters on this topic that simply says, no, that's not acceptable. It's not acceptable for pre-entry testing for confined space entry, nor is it acceptable for ongoing testing. You need to have a number. You need to be able to see if the concentration is changing, which you can't do if the only thing you have is a yes/no alarm. And be on the lookout for other kinds of contaminants. We've mentioned VOCs a few times. If you've got VOCs, a 4-gas instrument is not in your future, probably. You need a 5th sensor, which is the PID sensor. But it could be something else. It could be a cyanide sensor or an SO2 sensor or a chlorine sensor. There are just a lot of different contaminants out there that might be your contaminant of interest at your construction site. And remember that value includes more than the initial purchase price. But when you're thinking about what instrument to buy, I like to look at the benefits of the product and the cost of ownership over the life of the product. And that goes beyond the initial purchase price. It goes into the cost of ownership issues, how expensive is it to replace sensors, how long will the instrument live, what about after the sale support, are you going to get any, or are you just on your own out there? So these are all factors that you should think about, as well as the initial purchase price. And we are here to help you. If anybody has any questions, any topics that you'd like to have a chat about, please jot down my email address. I would love to speak with you. I promise I will give you the best nonpartisan advice that I possibly can. That's what we believe at GFG. And I thank you for watching this webinar. Have a great one, guys.
Great. Thank you so much, Bob. That was a ton of really cool information. We always love having you on here. So I'd love to throw it back to you before we wrap it up. Is there any talking points or anything you want our audience to keep top of mind or take away from today so that they can get a springboard into the right gas detection solutions?
Well, sadly, I've been in the gas detection business for over 40 years, and I've worked for a couple of absolutely great companies. And with that many, hundreds of thousands of instruments out there, occasionally accidents occurred. But there is one commonality to every accident where I've been part of the investigation team. It turned out when the accident occurred, the instrument was not being used or the instrument had not been maintained properly. So first and foremost, you've bought the bloody thing, use the instrument. And secondly, pay attention to what the manufacturer says you need to do to ensure that it's fit for use when you need it.
Fantastic. And I want to reiterate it. Bob just said it. Use it. If you have it, use it. Make sure you're checking it. Make sure you're testing it. Make sure you are using it. So Bob, thank you again. You can see all of his information and GFG's information on the screen there. Write it down, take note of it, reach out because they are going to keep you safe. So Bob, huge shout out to you. Thank you for being here today. Thank you for GFG Instrumentation Inc. for allowing you to be here today. And of course, we want to thank our partners, AD Safety Network, because without them, we wouldn't be able to host you. And I want to thank all of our dedicated safety professionals and the audience, because without them, none of this would be possible. So thanks again. Take care, stay safe, and reach out to your nearest GFG rep. All right. Bye, everyone.